Okay, so one of the things that we have to be able to do in calculus is actually apply our derivative tests to multiple situations. Okay, so this is a sample free response from the AP exam. Okay, so in this example, they actually give us the graph of f prime. So it says let f be a function defined on the closed interval from -5 to 5 with f of 1 being 3. The graph of f prime, the derivative of s, consists of two semicircles and two line segments shown above. Okay, so this graph right here, and it says right here that this is my f prime of x. Okay, so we're going to use that to answer all of these questions. So the interval is from -5 to +5, from here to here. Okay, find all the values of which f has a relative maximum, justify your answer. Okay, so part A is asking about maximums. Okay, so basically what we're going to be doing is we need to use this chart right here. Okay, how the derivative and the second derivative relate to my function. Okay, so when we look at this problem, we're going to be using this chart basically for almost everything. So since I have the derivative here, and it's asking us to find relative minimums and maximums, well, where do relative minimums and maximums occur? Well, they occur when my derivative is 0. So what I'm going to do is I need to look and I need to find my zeros. So this is the derivative. Okay, this graph right here is the derivative. So the zeros of my derivative are my possible critical points. So we have zeros here, here, and here. Okay, we're not going to worry about this one here for right now. Okay, because for them to be critical points, they have to be zeros, and for them to be relative minimums or maximums, they have to change sign on either side. Okay, so for it to be a maximum, right? So we're thinking about going back to our first derivative test. If we were doing a first derivative test, okay, basically we'd be doing the number line. So let's look at this as a number line, right? So right here at -3, that's a 0. Right here at 1, that's a 0. Right here at 4, that is a 0. Right here between -5 and -3, my derivative is positive. Between -3 and 1, this is negative. Here, this is positive, and here the derivative is negative. Okay? So if we think about it in terms of our test, when we look at these critical points, we say, wait a minute, here my function goes from increasing to decreasing. Here it goes from decreasing to increasing. Here it goes from increasing to decreasing at my 0. Okay? So maximums occur when my function goes from increasing to decreasing, or when my derivative goes from positive to negative, which means I have two relative maximums here. I have a relative maximum at -3, and I have another one at 4. Okay, so for part A, so the answer for part A is x equals -3 and x equals 4 are relative maximums because f prime of x changes from positive to negative. Okay, so basically what we're saying is is that because my derivative goes from the positive side to the negative side, that means my function goes from increasing to decreasing. Okay, I can't say because my function goes from increasing to decreasing. I have to use the information they gave me to tell me what's going on. Okay, so I have to use the first derivative, the information of the first derivative, and since the first derivative changes from positive to negative, that means that those are my relative maximums. Okay, so basically we're doing what we did algebraically, but we're instead of actually having to do it, we're getting our information from this graph. Okay, so part B says find all the values at which f has a point of inflection. Justify your answer. Okay, so point of inflection. Okay, so remember, I have the graph of the derivative. I do not have the second derivative. I can't really find the second derivative. I really don't even need to. So again, we go back to our chart and we go, okay, point of inflection. How do I know I have a point of inflection? A point of inflection occurs at a maximum or a minimum of my derivative. So that means my points of inflection can be here, because I have a relative max, here I have a relative min, and here I have a relative max. So I have 3 possible points of inflection. Okay? So now what we have to do is we got to figure out which one of those are actually. So let's look at these 3 points. Okay? So basically a point of inflection is where my function goes from concave up or concave down. Okay? It happens when I have a maximum or a minimum in my first derivative or a 0 in my second derivative, but we don't know anything about our second derivative, so we have to use our first derivative information. So basically we're looking for where it changes from increasing to decreasing or decreasing to increasing. Well, let's look. At -4, my function goes from increasing to, my derivative goes from increasing to decreasing. So that is a point of inflection. Here at -1, my function goes from decreasing to increasing. Here at 2, my function goes from increasing to decreasing. So all 3 of those are points of inflection. So look at part B. Part B, x equals -4, x equals -1, and x equals 2 are points of inflection. Why? Why are they points of inflection? Because f prime of x changes from increasing to decreasing or decreasing to increasing. So basically we're just writing what we said. We said, well, we had to check, did my maximum minimums, did it go from increasing to decreasing or decreasing to increasing? And if the answer is yes, then that means that they are points of inflection. So we just had to write what we were doing. Okay? Now, part C, find all the intervals where the graph of f is concave up. Justify your answer. Okay? So normally if we were trying to find concavity, we'd be relying on the second derivative test. But we don't have the second derivative, we don't have the second derivative test, so we have to rely on what we know from our first derivative. So here we go. I'm going to do C in green so you can kind of see it on the graph. Well, where is our function concave up? Well, it's concave up here when this information, when my second derivative is positive, or when my first derivative is increasing. Okay? So basically where my first derivative is rising. So from -5 to -4, my first derivative is increasing or rising. And from -1 to 2, my first derivative is increasing. So those intervals are where my function is concave up. So that's what we're going to write. So part C, f of x is concave up from -5 to -4, and was it from -1 to 2? -1 to 2. Why? Justify. Because, and we have to do it in terms of the first derivative. It's concave up because my first derivative is increasing there. Okay, so that's what we have to write. We're going to say that because f prime of x is increasing. And that's it. How do we know? Justify my answer. Well, I know that it is concave up there because the derivative is increasing. And then the last part, part D, find the intervals in which the graph has a positive slope. Justify your answer. Okay, well, the derivative is slope. So basically, we're looking for where the derivative is positive, because that's where my function, my original function's increasing. So find all of the places where the original function has positive slope. That's where my derivative is positive. Okay, so where is my derivative positive? My derivative is positive from -5 to -3, and from 1 to 4. So from here to here and here to here. And again, we're just using this chart. Okay? So part D. F of x has positive slope on the interval from -5 to -3 and 1 to 4. Why? Because f prime of x is positive there. Or you could have said that f prime of x is greater than 0. Either one would be acceptable. You could say that this is positive, or you could say greater than 0, because greater than 0 is positive. Okay? So basically now what we're doing is we're taking those ideas, that derivative test, and we're actually using it, but we're not creating the test ourselves. We're basically given the test. So when I changed it from this to that, you can obviously see it gives me the exact same information. The only difference is the way they gave it to us. And this is something that you're going to have to get used to, is finding information from charts and graphs.